Alrighty, so today we are doing molarity and dilutions. This is also going to include a little bit about concentration because molarity is a measurement of concentration. Concentration is the measurement of the amount of solute dissolved in a solvent. A more concentrated solution is going to have a higher concentration because it has more solute dissolved in the solvent. In a dilute solution, you have a lower concentration. This is because there's less solute dissolved. This plays directly into dilutions, and we're going to talk about that in a little while. Molarity is that measurement of concentration we use most commonly. It's not the only measurement, but it is definitely the most prominent one. It is a ratio of moles of the solute per 1 liter of the solvent, or per liters of the solvent. This gives us the molarity, which is written as a capital letter M. Key terms here: concentration, concentrated solution, dilute solution, and molarity. If you need to write those down, pause the video to do so. If you did not write down this equation, pause the video to do so. Units for molarity, you can just do capital M, but this capital M stands for mole per liter. Let's start out with some examples of molarity. Remember, we have moles of the solute per liters of the solvent, giving us that capital letter M, or molarity. IV saline solutions are used in hospitals to hydrate patients. Saline solutions have to have an amount of salt in them in order to prevent the patient's blood cells from overhydrating and bursting. There are different molarities or different concentrations of these saline solutions depending on what the patient is experiencing. If they have higher salt levels, you might want to have more or less salt in the saline solution, depending on your goal for their blood. We want to find the molarity of a 100 milliliter saline solution made with 0.9 grams of sodium chloride. There are kind of two ways that we can do the math here. I will show you one and then show you the other. Starting off, we're given grams of our sodium chloride. We need moles to be able to plug it into our equation. So the first thing we need to do is convert from grams to moles. Set up that conversion factor of 0.9 grams sodium chloride to moles of sodium chloride. Remember, we use our molar mass here, which is the grams of sodium chloride per 1 mole of sodium chloride. Pause the video to find that molar mass. All right, the molar mass will be 58.44. We cross out our grams of sodium chloride because they cancel. Divide 0.90 by 58.44, which will give us 0.015 mole of sodium chloride. Next, we need to find our liters. We have 100 milliliters. Well, we need to convert our 100 milliliters to liters. We'll do this by 100 ml divided by our 1,000 milliliters per 1 liter, which will give us 0.1 liters. Knowing about this, we would plug in our 0.015 moles to our equation, placing that over our 0.1 liter. And this will give us 0.15 molar NaCl. Now the other way that we can do this is working through it almost exactly the same way by first solving our grams to mole. And then at this part, we can go ahead and add in that conversion right here. By dividing 1 liter by the 1,000 milliliters. This will also give us 0.15 molar NaCl. This here works because we are already looking at this as a 0.9 grams per 100 milliliters. So adding this step in here works just like doing these two steps separately. Either way, the answer would be a 0.15 molar solution NaCl. We can also use molarity to find amounts of solute or solvent in a solution by flipping the equation. Remember, our equation is capital M for molarity equals moles solute over liters solvent. Here, we want to identify how many grams of sodium hypochloride, which is what this is, are in a 1.5 liter sample of a 0.70 molar solution. Plugging in the things we know, we have a 0.70 molar solution NaClO, which is equal to our 1.5 liters divided under an unknown mole of our solute, which is our sodium hypochloride. We need to solve for x. So 0.7 multiplied by 1.5, that will give us 0.467. mole, but we're looking for grams, not moles. So what we need to do next is convert from our moles to get grams. 0.467 mole of sodium hypochlorite Remember, molar mass is 1 mole. Per the grams, the grams of the substance per 1 mole. And we use our molar mass, which is going to be 74.44. In this situation, we are going to multiply, and this should give us 34.763 grams of sodium hypochlorite. Remember, 3-part answer: number, unit, substance.